after I put it in there, then they're not going to be able to see it. So you'll probably see it a few times, but since you arrived early, wanted to make that available to you. And we'll get started here in just another minute or so. Okay, well, welcome everyone. I'd like to welcome you to our webinar regarding balanced mix design, the 8 tasks for implementation, as well as findings and challenges to implementation. As a friendly reminder, we ask you mute your microphone and turn off your video to save some bandwidth. My name is Tim Aschenbrenner. I'm with the FHWA Office of Infrastructure Pavement Materials team. This is coming to you as part of our FHWA University of Nevada Reno Cooperative Agreement. We have a cooperative agreement on development and deployment of innovative asphalt pavement technologies. We're really all about implementation. We're working about 15 or so tasks right now to help meet states where they're at and then raise them to the next level of where they want to get to. And this is a webinar about some of the implementation items we have. So for today's activity, we'll have about a 45-minute plus or minus presentation followed by Q&A. We'll have 45 minutes for Q&A, so there'll be plenty of time. Be sure to enter your questions into the chat and we'll get to them after the presentation. Before we get started, I just want to remind you about our bi-monthly webinar series we have. I'll put a link in the chat pod to access the past ones, but we only have one more webinar coming in the future as part of this particular cooperative agreement, and that'll be on March 7th. We're going to go through all of the products that we developed and the impact of those products on FHWA's strategic goals. Ellie Hodge with University of Nevada, Reno will present that. That'll be the last webinar for this cooperative agreement. We do have another cooperative agreement that's starting, so we'll hopefully start another webinar series in the near future. So at this time, I'd like to turn it over to Derek Niener-Plant. Derek's with our FHWA Resource Center, and Derek will be giving us the presentation. So turn it over to you, Derek.
Thanks, Tim, and thanks everybody for joining us today for this webinar where I'm excited to speak to you about what we have found through our balanced mix design peer exchanges and focusing on implementation of balanced mix design and what are some of the findings that we found from talking to multiple agencies and contractors, and primarily what are the challenges that are left to overcome to properly implement balanced mix design. I appreciate everyone joining us today. And just as a little bit of a background, I've been with Federal Highway for nearly 4 years now. And prior to that, I was the state pavement engineer for Maine DOT, and I still reside in Maine, although working for the Resource Center doing all things asphalt across the country. So let's go ahead and get started. First, I want to put up our disclaimer slide showing that this work is from the U.S. government. We don't endorse any products or manufacturers. Any of the standards that we reference in this presentation are private voluntary standards. They're not required under federal law, and Federal Highway is the source for all these images in the presentation unless otherwise noted. I also want to acknowledge the moderator, Tim Aschenbrenner, and my colleague, Ellie Hodge from University of Nevada, Reno, as we really work together on balanced mix design under the Federal Highway. University of Nevada, Reno co-op. For much of this information was generated through number of the tasks through that cooperative agreement. So it was derived from that work, and really kudos and acknowledgements to those two, as they are key in all of this work that I'm going to be talking about today. And finally, some abbreviations and acronyms that we may be using throughout the presentation in case you need to look at this later. So I'll start with, why are you here? What do you want to get out of this presentation and this webinar here today? And if I could sum it up, I'd like to communicate some of the challenges of balanced mix design implementation as it's going on around the country, as heard from state DOTs, those agencies and contractors across the country that we've heard through our many activities in recent years pursuant to balanced mix design. So, the concept of balanced mix design is out there, certainly. It's being discussed a lot in the asphalt materials area. What are we going to do about it for implementation, and what are some of the challenges that we're going to need to overcome to put this into practice? So I am going to start with a bit of background, just to comment for those that maybe not eat, breathe, and live balanced mix design like some of us feel like we do, just to provide background so that we're all on the same page about balanced mix design and what are we talking about here. So starting with the definition, the AASHTO definition of balanced mix design is listed there as far as providing what that is for an asphalt mix design. What I like to talk about this as is a design philosophy that's trying to optimize mix performance. I like that verb optimize in that definition there in the white box, against distresses that are pertinent to how I'm going to use the mix. And that includes the climate that I'm going to put it in, the traffic I'm going to subject it to, and the region in which it's going to be placed. So that's really the way to think about this, is an optimization of the mixture against how it's going to be used, as we know that our mixtures are all different, right? That we're going to be using them differently, etc. I also put a plug in here for TRB's eCircular. That is a glossary of terms for balanced mix design, as we often have, our own language in engineering. Asphalt is no stranger to that. And this glossary was put out from TRB to really kind of get to a consistent language when it comes to balanced mix design. So I encourage you to check that out as well. To give a scope on the countrywide and the idea here that numerous states are moving or at least investigating balanced mix design for use in their asphalt mixtures. This image comes from the National Asphalt Pavement Association and their Balanced Mix Design Resource Guide, which is a wonderful resource to look at to see what's going on countrywide and get a lot of information, especially if you are newer to the concept of balanced mix design. What I would say, and to keep in mind here, is to take away from this is you see the different colors. This is showing the different approaches of balanced mix design. That's less important, more that most states are investigating balanced mix design at this point. And even those that are showing as gray, I'd say conservatively half of them are considering balanced mix design in this case. So it's really getting momentum nationwide, hence the work that we put in on the UNR Federal Highway Cooperative Agreement to try and document what some of these activities that states have been doing and some of their challenges. So Tim put in a link in the chat earlier to a tech brief that Federal Highway has put together. It's now been a couple years. This was done in conjunction with many others in the industry, including the National Center for Asphalt Technology, for the 8 tasks that can be undertaken to implement balanced mix design. Now, we use the word tasks very intentionally here. They are not steps in the way that 2 depends on 1, etc. And not all of these tasks need to be considered by every agency, every situation. Everyone is different in their organizational structure, staffing, their industry, asphalt tonnage, etc. We also use the word task intentionally because there are interrelated activities. There is some critical path items. This is an example schedule. And one thing to take away is that it will take time. There are challenges that are going to be encountered to implement something as wide-ranging as balanced mix design. Tim put the link into the tech brief, so if you haven't seen that, I also encourage you to check that out. So what we're going to talk about and focus on really here is the results and what we heard from our balanced mix design peer exchanges that we've been doing in the past year or so across the country. You see a map here of the balanced mix design peer exchanges that we've held in the past year. We've had 5 in person, and we have a mega states peer exchange that's been doing virtually California, Texas, and Florida on a regular basis. And we also have others that we're going to be doing, including a mid-Atlantic one for the states in the white on the East Coast. But either way, we've tried to hit multiple regions and have these in-person discussions between agencies, and also listen in other venues to contractors and other stakeholders about what are going to be the challenges to balanced mix design implementation. So as we put these together and thought about these after conducting many of these peer exchanges, we've kind of centered on some of the critical challenges that we've heard. And as good engineers and what we would consider logical thinkers, we like to categorize them, right? And as looking at this, I have to give credit to Eli Haj, our colleague, that really kind of proposed this way to think about it. And that these challenges kind of categorize themselves into management challenges and technical challenges. I think our industry, we're very quick to think about their technical challenges and kind of jump to technical items. There's so much more than that, and that includes these management challenges that we'll be talking about through the rest of this webinar. So I have a graphic here that's going to show these challenges and how we categorize them. So to start, we have the management challenges and some examples here of what I'm going to go over in more detail under management challenges. So these things include things like how to balance risk, what's the cost benefit of doing really anything new, including balanced mix design, how to allocate resources and whether there'll be enough resources to tackle balanced mix design, engaging stakeholders, etc. On the other end, we have technical challenges. And some of the technical challenges, again, often very easy for us to think in the engineering world, are concepts like validating balanced mix design tests, the variabilities that we see in results. How does that relate to the procedures and the protocols that we've established for balanced mix design? Use of databases, quality assurance, and how we're going to handle volumetrics, all very critical challenges on the technical side. And of course, not everything is easily put into a bin, right, and categorized. So we have some that we feel overlap. And that includes how do we integrate something new like balanced mix design into existing practices? How do we train and provide education on balanced mix design as it's something new? And then the challenge of sharing information across state boundaries, across regional boundaries, and collaborate among peers so that not everybody has to, quote, go it alone, end quote. So in listing these challenges and those that I'm going to dive into a little bit deeper over the next half an hour or so, we want you to be mindful in a couple things. Not all states, not all areas are going to experience every challenge that is listed. All of these challenges are listed if they were significant, even if it was only significant for a few states. So not all of these apply to every situation. And we can sometimes feel that this is a tough presentation to listen to because we're listing all the challenges or problems that stand ahead of balanced mix design implementation. I guess our message would be, don't lose all hope by hearing all these challenges. Many of these challenges have ongoing efforts to address these, or there's already been solutions implemented to handle them by some states that other states could learn from, things like that. So these aren't all necessarily challenges that we have no idea how to handle. We wanted to categorize every challenge, even if they were there and there is a path to addressing them. So don't lose hope, I guess. And we want to acknowledge, although our physical peer exchanges that we held were with only agencies, we have heard similar challenges from contractors, and we've engaged industry in a lot of different avenues through our cooperative agreement and a lot of our balanced mix design activities. And we're hearing a lot of the similar challenges from contractors that we're going to list that were shown by the agency. Often it's a slightly different perspective, But we summarize some of these challenges from the industry side here. And I have an image here courtesy of the National Asphalt Pavement Association that shows some of the thoughts from industry on balanced mix design. So some of the overlap that we heard from industry is that implementation is going to require resources, often at a time when those resources are scarce today. That often we get a resistance to change. I know what I'm doing now. I'm comfortable know what I'm doing now. Why should I change? Concern or challenge that BMD tests may not be able to fully replace what we're currently doing in a production environment and quality assurance. And another one being variability. So we'll hit on many of these, but I think there's a lot of overlap between the challenges that would be specific to contractors in industry as opposed to the agency. So we're going to go through these by category, and we're going to start by tackling the management challenges and talk about some of these and some of the specifics that we heard. We'll start with the concept of change management, and this really just boils down to a resistance to change. And I think that's natural in our industry, among others, that we're familiar with the traditional mixed design. And I've often heard before a mentor would describe change as pain to me, that you're asking someone when they change to want to go through some sort of painful period, extra work, whatever you want to call it, to change. So there is that requirement to shift in some way. So there's the idea that there's challenges and able to inspire confidence that balanced mixed design will provide benefits enough to justify the change, that many agencies may have competing priorities in the innovation that they're willing to tackle and give resources on. Obviously, asphalt materials is not the only part of a DOT or an agency. They have other things going on as well. There are some change management strategies that we've seen, certainly communication, being able to identify local champions to get buy-in from different stakeholders, both within the agency and outside. A big thing is communicating the why, not starting with the what balanced mixed design is, but what does it stand to gain you? What benefits could be put into place or realized by putting balanced mixed design in? And then having a plan, creating a plan with some timelines to put at ease some of the concern about change and having it be this big unknown. Two others in the management challenges that we saw were cost benefit and then risk management, risk and specification management. When we talk about cost benefit analysis, we need to be able to demonstrate benefits to stakeholders for balanced mixed design, or again, if you want to generalize this for nearly any innovation, justifying the investment. There isn't necessarily a lot of work that goes and looks at balanced mixed design cost effectiveness because it's relatively new. So there isn't work that shows, oh, we implemented balanced mixed design and this is the cost benefit that we saw out of it. So that can be a challenge to justify the investment in resources, et cetera, to get there. And that may be to justify the investment, the why, through improved pavement performance and longevity, reduce maintenance costs, or to help support other efforts like sustainability, as there's a lot of progress and movement on sustainability. If I move to the right side of the slide and talk about risk management, this is where mixed design acceptance procedures, you want to know that you're complying with industry standards. And again, moving to something new provides that risk on parties, that what is this new item and how are we going to be able to handle it? So being able to meet the challenge to identify and mitigate risks with the implementation of balanced mixed design. And those could be on all different areas. The extra costs that it might be to implement balanced mixed design, performance issues that you might see, being able to meet the specification on the contractor side, if I take that type of approach. Always need to be thinking about things in the area of the risk that it presents to both the agency and the contractor, and thinking about those challenges from a balanced mixed design perspective is important as well. A big one that we heard, especially from agencies, was resource allocation. And in this is not just funding, this is personnel, their time, funding, being able to get equipment, not only initial investments, but ongoing costs. Things we often heard is that staffing is challenging enough as it is, and that the need for BMD might make that even more challenging, as many agencies reported that they have competing priorities within the agency. That again, asphalt materials are not the only thing. There are innovations in other areas that may require resources. So you are competing to get those resources. Considering staffing resources and the workload for implementing BMD. That figure I showed of the tasks, that's work often that needs to be done by the state DOT. And we've often heard the sentiment that there is 1, 2, maybe 3 people in an agency that are working on balanced mix design, and they feel overloaded as it is. And finding qualified workforce to be able to address maybe a leveled up procedures, something beyond volumetrics, might be an additional challenge. So I don't think this is surprising to anyone in the audience and certainly the agencies about resources, but it is going to be a challenge that's going to need to be overcome in order to implement balanced mix design. Another one that we would categorize on the management challenges side of this is implementation planning. Many we found kind of wanted to start with balanced mix design and get a test and just start testing. Well, there's a planning that comes along with something as large of a scale as balanced mix design. So things that we found, that agencies found as a challenge, was being able to come up with a formal plan and defining goals and scope of what they were trying to get out of implementing balanced mix design. That's really a crucial item in order to think about your why. Why am I doing this? And what does balanced mix design look like in my given agency, in my state? So it's very key as a challenge because it can help avoid missteps and minimize rework when you come up with that plan and formalize it with tasks and timelines that may change, but it helps provide and realize a greater focus on the timeline and avoids those missteps. But often it's something that's a challenge to field to do early on in a multi-year process. And finally, on the management challenges, we have stakeholder engagement. As agencies reported having a challenge to find ways to partner with their industry to get buy-in. And often this came in the tasks of task forces, asphalt stakeholder engagement groups with their industry, etc. This involved getting champions to get involved. And a lot of the challenge here was having clear communication. Why, from an agency standpoint, is balanced mix design something that they're interested in? And it goes back to that goals and scope, that having a why am I doing this? What are my goals to achieve by implementing balanced mix design? And what does my scope of balanced mix design look like? What does it look like for our given state? So that requires engaging stakeholders early on to get them on board early on and fostering that collaboration throughout the process. Balanced mix design often is going to meet challenges if it's something that the agency is doing on their own without collaborating with their stakeholders. That sums up some of the major things we saw on the management challenges side. So we'll transition over to the technical challenges and some of the major ones that we see here from talking to agencies and contractors across the country. The first one that we want to talk about is balanced mix design test validation. And when we talk about validation, what are we talking about? We're talking about the relationship from field performance to whatever that BMD mechanical test is. That relationship has got to exist and has got to be validated because that's what we're trying to improve upon. We're trying to step away from specifications or tests that may have a looser relationship to actual field performance. So we want to make sure, and the challenge is to identify distresses of interest for a given agency, what affects field performance for that given state, and find mechanical tests that will relate to that. It's really crucial for developing rational and defendable specification criteria for mix design approval and eventually acceptance. But the challenges that we heard from agencies is, how do they do this? How do they gain confidence in the mechanical tests and identify that correlation with the stress of interest? We found agencies felt that without a documented plan, they were facing a delay in starting validation efforts. They kind of took the BMD test and just started testing some of their existing mixes. Rather than maybe thinking validation first, as one of the major challenges with validation is time is the enemy, is that you want to see field performance differences with BMD test differences, and that's going to take time. Another challenge is that although it seems kind of obvious to take existing pavement asset management frameworks that we use often for asset management of our pavement networks, that would make sense to use to track field performance. But often that integration between asset management data and materials data does not exist in a lot of agencies, and they found challenges being able to make that link. And BMD field projects often haven't been out there long enough. They've been mostly 3 years old, and that's not long enough to see that differentiation in field performance. So we heard a lot of challenges, and I think a lot of challenges still exist for agencies on really how to put this validation task into practice. An additional one is testing protocols and procedures, where these are new tests, just like anything else. We are looking to achieve consistency so that when different labs, different people sample and test, we are comparing apples and not apples and oranges. So this includes both lab and field produced asphalt mixtures, as many have found the challenge that those two don't line up. If I make a mix in the lab and I make it in the field, I'm getting differences. This also includes some challenges for sample handling and conditioning protocols. Something different with these mechanical tests is that it's picking up things and differences that we're not used to showing up in our typical volumetric testing and analysis. Concepts like lag time and dwell time. Lag time, where that's how long after initial mixing are the specimens compacted. If you want to think about how long they sat in that sample container, was it a day, a week, a month, a year? And then dwell time, how long after a sample is compacted into its final specimen form to when it gets tested. Does that impact? The thought being that as this mix sits out, it's aging, potentially oxidizing and aging and stiffening over time. And some have reported seeing differences with how long these samples come out. Now, there's ongoing work to try and really holistically look at the effects there, but we never had to worry about that with volumetric testing. And it is a challenge for this, that sample handling, preparation protocols have often got to be a lot more defined, as there's limited information as to reheating, handling, etc. But it's already showing that we need to worry about it a little bit more than we did before. This includes big topics like aging and moisture damage, where there are many unknowns at this point, and many agencies feel like they don't know where to turn at this point when it comes to topics like aging. And that kind of segues logically into the idea of variability. And a large concern or challenge with balanced mix design tests is that they are more variable than the tests that we are typically using today. That variability, what does it do? If you have larger variability of test results, it erodes confidence. And that makes sense. If you have a test that, you get 31, 32, 33 when you do replication versus 20, 30, 40. Your confidence is going to be affected by the replication of that number. And also sensitivity of test results. Are these tests sensitive to the different things that we can change in an asphalt mixture? So in variabilities, things and challenges that need to be addressed in one way or another in our industry looking at the future is ways to reduce test variability, which we've done many times before across many industries and infrastructure, that we introduce a new test and we drive variability down. So that's going to be something that's going to have to happen here. But concerns with variability, especially in the cracking tests, undermine confidence in balanced mix design, which affects some of those management challenges that I talked about earlier. Confidence, which is hard to get stakeholder engagement, etc. There's concerns about differences in test results with different devices that are out there, or sensitivity or differences in lab test results between mix design and plant produced material continues to be a challenge. That if I mix it up in the lab today, I think I've got this number. I go out into the field and I get a different number. That's going to be a challenge for mix designers, as they often start in the lab. Another one that we heard definitely from the agency side was the topic of databases and setting up databases. Many agencies acknowledged a need to organize an initial balanced mix design database. You're talking about having data and tracking it over years against field performance and having this data for the future. That logically leads you to having a database. Now, doing that brings in a lot of challenges. So it's something where you're looking to track not only testing parameters, but tracking field performance as well. And as previously said, that linking balanced mix design data to construction data, quality assurance, and field performance really has very rarely been done in practice. From a high level, it sounds kind of easy. Well, let's just link all those together. Many reported that there are many logistical challenges within their agency to link these different databases, to be able to get from mixed design information and know where that was put in the field is not as simple as it sounds. Many felt that there was a need or a challenge in order to know what data to keep, what data is important to keep long-term for these tests, to maximize the data fields and use raw data, as we have many examples of keeping raw data can be helpful down the line if a test parameter changes, et cetera. But then that gets into larger and larger databases that are harder to maintain. A couple key ones here, wrapping up on technical challenges, is the pathway for use in quality assurance. And I think this challenge especially is coming to the forefront. Balanced mix design, by given its name, is obviously involved in mixed design. And a lot of the work to date has focused on its use in mixed design. Now, as the research community is kind of continuing to look forward, it's almost like the community is looking forward to now what needs to happen to bring it into quality assurance. As I like to say, there's a whole new can of worms to bring a test like this into quality assurance beyond mixed design. So there's a pretty deep desire by agencies and contractors to use balanced mixed design principles in mixed design and beyond into acceptance, as the thought was that if it matters, then why wouldn't we use it in acceptance or quality control? Now, balanced mixed design for acceptance has many different options, and I'm actually going to show that on the next slide. But the challenges that we hear for this is things like aging. If many feel that aging is necessary in order to get an accurate cracking, well, aging takes time, and that's a challenge within the area of quality assurance. There's also the need for increased sample frequency for balanced mixed design tests, but these tests take time, often longer than our current tests. And frequency of testing comes into risk for agency and contractors as far as, are you sampling frequently enough to get an accurate picture of what's being put out there? And this is where some agencies are looking at surrogate balanced mixed design tests that are quicker to turn around tasks faster. And then challenges like assigning BMD test weight. Where does the role of volumetrics come in? We'll actually talk about it as a separate challenge a little bit. And that there's a fear, I guess, or a concern that too much focus on balanced mixed design for pay might lose sight of production control and being able to maintain consistency as we've attempted to do through quality assurance activities. This is a slide I like to show and just dive down on this quality assurance topic a little bit, that again, a majority of the agencies and contractors, especially we've heard, they want to go and bring balanced mixed design to field production eventually, because if these tests relate better to field performance, why wouldn't we use them? And that logically makes sense. But the question is, what does the use of balanced mixed design and quality assurance look like? And this is some of the options, from none to just leaving balanced mixed design in mixed design, to some sort of initial startup or verification through a test strip or trial drop. Then you could go to go, no go, checking in every once in a while on these balanced mixed design tests, but they don't affect pay, to acceptance, and then acceptance with pay adjustment. I think the challenge that we've observed here is that there really is increasing difficulty as you go down these options, and more things that need to be considered in order to properly integrate a balanced mixed design test or a mechanical mixture test into quality assurance. And something you need to acknowledge is what is different between these balanced mixed design tests and what we're using now. And the acknowledgement is that these tests often take longer time to sample, fabricate, and test, and more of a significant effort to prepare and fabricate specimens to get one result. There's a lot more effort into that. So it may be challenging to keep current sample frequencies, but less often sample frequency leads to risk, right? So another one of the things is variability, both between lab and within lab, as many of these tests don't have established precision and bias statements yet. And variability, again, erodes that confidence in the results. And the last one is that we often are observing wider range of typical resulting values from these tests. And my example would be asphalt content. For a given mixture, asphalt content is often somewhere 4, 5, 6, maybe 7%. And the variability in those tests don't vary much, whether you have a 4% asphalt content or 7% asphalt content. What some of the early work in acceptance testing, things like that, of production samples are showing that some of these tests, especially maybe the cracking tests, their values, depending on where you are in the country, can change radically. And that some of that variability, even when you try and normalize it by doing a coefficient of variation, can change radically as well. The last technical challenge I'll cover here is what to do with volumetrics. We've been using volumetrics. We believe that volumetrics was a step above what we were doing previously, right? But volumetrics properties alone have shortcomings. That's one of the reasons we're investigating balanced mix design. So there's an obvious thought to relax volumetrics, but the challenge is what? How? How much to relax? What properties to relax? And it's kind of a chicken and the egg thing in a little bit. There's this desire we need to confirm balanced mix design test results to pavement performance through validation. But where, if we don't do that first, are we going to not reap some of the benefits by relaxing properties? So you've got this push and pull between innovation and, again, risk. We want innovation. That's a great benefit of potential balanced mix design, but you got to have an ability to greater access and use our materials better through innovation, but we've got to allow that. So what do we do with volumetrics? So some of the challenges being able to instill confidence in the balanced mix design tests that we can move away from some of those volumetric properties. Will stakeholders feel enough confidence to step away and start to relax those, which is key to getting some of the benefits? Can the role of volumetrics in mixed design and acceptance stages differ? The idea that maybe in mixed design, a given volumetrics target is not necessary, but maybe you use volumetrics in acceptance to control the mixture consistently. And which volumetrics are still properties are still important? Which ones are still important to use? I think many feel that volumetrics are still important properties, but maybe they don't have a specific spec. So it really boils down to the challenge of the question that we're hearing: which criteria do I relax when I relax things, and by how much? And how does that fit into quality assurance? Finally, I'll get to my overlap areas before wrapping up. And we have 3 overlapping areas that kind of fit between management and technical challenges. First being integration with existing. So there's the need to bridge the gap between what's being done on the research side and what's actually practical and put into place. And some of that means identifying what gaps are there to be able to provide proper balanced mix design training, to be able to bridge the gap between management and technical perspectives, to find a technical solution that also meets what you have from a management standpoint or resource standpoint, and compatibility with what you're doing now. Many agencies have certain mix design procedures or certain ways that they do it. They might need to think or rethink some of those long-held kind of standards on how mix designs are handled in their lab, or some of the logistics of that, to be able to integrate properly with balanced mix design. A big one here, again, is the frequency of testing. That poses a significant challenge at the start of implementation, because many implementation efforts would have you just add balanced mix design to your current testing. Well, the resources may not allow you to do that. And frequency of testing, with the time that these tests take, that is a significant challenge to be able to achieve those frequencies. Second one being education, training, and skill development. And I think this would probably be, echoed by many of our participants here, that this continues to be a major challenge in balanced mix design, among other places. Many are experiencing high staff turnover, so there's this need for continuous education, where maybe we thought of training as we trained everybody, we did that. Now it's more of a continuous thing. Specifically for those that are unfamiliar with the balanced mixed design concept among the people that are actually doing it in the field, project engineers, lab personnel, etc. So there might be a need for formal training workshops on a wider scale across our industry, not just the people who are implementing it, but the people who are going to need to do it. New qualifications may be needed, especially for maybe mixed design. Balanced mixed designs may require more knowledge from a mixed designer standpoint. We have to acknowledge that as well as the ability to interpret the data, do the testing analysis. Some of these tests do take a certain level of technician that maybe couldn't do some of the volumetrics. And then finally, collaboration and information sharing. This is a challenge as, Super Pave was more of a national level specification on balanced mixed design, or excuse me, on mixed design. Balanced mixed design, by definition, is not going to be a national level specification because it's supposed to be tied to a given agency or area's distresses and how you use your mixtures. So that's really key. So collaboration is still good so that states and areas and agencies and contractors don't have to go it alone. So there's the challenge of how do we initiate regional collaboration so that when we can share resources, we can reduce the burden on individual agencies to be able to share some of the technical things that they've learned, some of the management information, leverage geographical proximity and similarities in climate where that's available. I'm from the Northeast part of the United States. There's a lot of states in a small geographical area. Is there a way that coordination collaboration can happen there so that you don't get very divergent specifications? Are there ways to facilitate accelerated implementation by promoting consistency whenever feasible, as that we don't get 50 drastically different states with drastically different balanced mixed design specifications? And having a time to find those opportunities and exploring what's out there. And this is, again, another one where there is ongoing work among a lot of these challenges that, as I said earlier, that there's existing efforts going on to do these type of things. So just listing the challenge doesn't mean it's not being worked on, but it does exist. So that's the challenges that we've often seen we've seen pretty remarkable consistency around the country. Obviously, there are some isolated areas that are more concerned about some challenges over others, but these are pretty consistent. And although contractors and industry have a different perspective, many of them see the same type of resource challenges under management or variability challenges under the technical items. So there is overlap there for sure. So with that, as I begin to wrap up here, I want to let you know some resources that are available from what we're doing at Federal Highway and our UNR cooperative agreement on the topic of balanced mixed design. One is our implementation workshop that we had started doing virtually that's now offered in person. We've been doing this across the country where we go through those 8 tasks to implementation of balanced mixed design to a given agency and your contractors all hearing it and having a discussion about it as a great way to kick off or even more formalize your balanced mixed design efforts. So that continues to be available through the Resource Center, and I'm the contact for that. So please feel free to reach out to me if you're interested in that workshop. This is where we've been across the country between completed virtual workshops in person that we've begun to really get into as they just get a lot more collaboration, some of those that we have planned in the future. In addition, some of the few balanced mixed design resources that we have is the tech brief, as Tim showed, on the 8 tasks for implementation, as well as that TRB BMD glossary. I'd also be remiss if I didn't mention a great document by the cooperative agreement on adjustments to balanced mixed design mixtures to meet specifications. That's another great tech brief that is out there and available right now. So if you navigate to our Federal Highway Balanced Mixed Design asphalt mixtures site, a lot of those resources are available. So there's a lot of information that will continue to come out, and we at Federal Highway are going to continue to work and try and support, listen to agencies and contractors and industry to be able to see what resources are necessary to address these challenges so that balanced mixed design and implementation gets just a little bit easier. So with that, I'll wrap up this presentation. I'd be happy to take any questions, and I appreciate everyone's attention. I'll turn it over to you, Tim.
Well, great job, Derek. Thank you very much for the enlightening presentation. And at this time, we have plenty of time for questions. If you do have a question, feel free to type it into the chat pod there. We'll go through them as they come up. Well, we don't have any questions right now, so I was going to maybe ask you, Derek, some thoughts. Maybe if you could go to slide, I think it was 31. That's had all the lists of the challenges all bulleted out there. Yeah, so I guess as you look at all these management and technical challenges and all the bullets there, certainly we've been around to many states and everything. I guess the challenge a state has depends on where they're at in the implementation process. But in terms of what you've seen, what do you think is the biggest one? Or if you can't think of one, maybe one or two challenges you're commonly seeing right now.
Yeah, Tim, I think.
And maybe before you answer that, I'm going to ask the participants, if you're in the process of implementing balanced mix design, feel free to enter in the chat pod which one of these bullets you have a challenge with right now. Maybe it's the general technical challenge, or maybe it's a general management challenge, or if it's one of the specific bullets. Yeah, feel free to type that in. I'm kind of curious where you're at as a participant. And now I'll turn it back to you, Derek, and see what you've seen around the country.
Yeah, thanks, Tim. I think certainly it certainly does depend on where they're at and all of that. But a couple that come to mind is on the technical side, I'll start there first, is I think validation is a big one that is so crucial to coming up with rational and defendable criteria that many states are struggling with in how to do, as a lot of the validation efforts in the order are necessary to come up with that criteria. And it often involves building test sites or having accelerated loading or forensic studies. There's many different ways to do it, but it's a key thing in that it takes time, like I said. And I think the challenge is kind of getting that started. So I've heard that a lot. I'll also say on the management challenges, one that just stands out to me is resource allocation. I think my comment about, we had a lot of these peer exchanges, and I felt like I heard the sentiment that, I'm quote, the one that's doing balanced mix design for the state. It's not like I have a team of people that are working on it. It's me or a couple other people within the state that are working on it. And so obviously that's a big load to take on to be able to handle all these tasks and things like that. So those are the two that just pop to my mind. I still think, on the technical side, variabilities and what to do about QA are massive ones as well. But I think if I had to say consistently across the states, those are the two that come to mind for me.
Okay, great. And we're starting to get some responses from our participants. So this will be interesting to share from Rick Bradbury in Maine, really putting that cost benefit analysis to justify to upper management the move to balanced mix design is a current challenge there. Rob Hinman from our Ohio division office is a challenge with the variability of the testing, and has embedded a question in there also. And I don't know what your thoughts on this are, Derek, but as we further refine not only the test procedure, but the sampling and handling procedures as well, do you think we'll be able to reduce test variability to have higher confidence in the results?
Yeah, I guess from some of the work that's been done out there, I think the test itself has variability, right? We all acknowledge that. I think some of the work that's been done says that a significant amount of the variability that we're observing in the test results comes from specimen fabrication. So I do happen to believe that if we are able to do enough on the specimen fabrication, I don't know if it brings the variability down to where we are today with some of our tests, but I do believe it's significant and worth the effort to look into specimen fabrication because it is so key. The thing that's tough about it has been doing the same thing for years in a lot of places. And now we have to kind of rethink a lot of that. But I do believe that's going to be a key challenge, that there's a lot of work going into lag and dwell right now. that we can handle a lot of those variabilities and hopefully eliminate or reduce a lot of them.
Very good. And another challenge that's popped in, glad people are sharing. From Utah, we see the cracking test with aging, because we know that that's going to be a big key to performance. And so aging is one that I know you had mentioned, Derek, but I don't know if you can offer any additional insights there,
Yeah.
because I know Utah is not the only one facing that challenge.
100%, Tim, and Scott as well. I think aging is a huge one that many feel it's going to be necessary because our pavements don't crack right out of the plant, right? They crack after they age a little bit, and that aging makes cracking more likely because we're stiffening the mixture over time. We all know that. The thing is, what aging procedure to use? There's multiple out there. It's almost like we transitioned from, I felt like everybody said 5 years ago, there's too many cracking tests, stop making cracking tests. That now I think we're at the point where people are almost saying there's way too many aging procedure options out there. And maybe we'll coalesce among some, and they all very get into the technical details of some of the pros and cons, technically, the pros and cons of just practically of some of the different aging methods. But I think that is definitely a major one that many agencies have expressed to us, something along the lines of, yeah, we know we should do aging, we should investigate aging, but I don't know where to start. I don't know which one to do because I'm kind of that paralysis of I don't want to choose the wrong one. So I definitely understand that and echo that, Scott, that thought from Scott.
Okay, very good. Now, another question here from Jason and I think this is the Jason from our Eastern Federal lands. If an agency doesn't typically offer training for contractors, are there good training classes to direct them to? So I guess I'd be looking for training classes contractors can attend.
Yeah, so I guess it depends on what your goal is with trying to train them. So a couple resources that come to mind. Obviously, the previous webinars that have been done through this series, a lot of them on balanced mix design. That's a good place if they're thinking about more implementation. If you're thinking about how to meet balanced mix design specifications, I think you have certainly the tech brief that I mentioned earlier. And I'm wondering maybe if Ellie or Tim want to add that link in there into the chat about adjustments to meet balanced mix design tests. That's a great one. And that presentation has been given before. And so that's an excellent resource. I also think, and somebody could correct me if I'm wrong, I think NCAP, the National Center for Asphalt Technology, has a mix design course where they are incorporating balanced mix design into that. And so I think you're going to see more resources, Jason, where now the shift has gone from, well, what's the right cracking test and all that, to now providing resources to actually do balanced mix design. Those come to mind, but I think those are going to multiply in the next year or two.
Very good, good. Okay, next question is coming from a contractor perspective. And here, thinking about the cracking tests, and I assume the variability that is associated with the cracking tests and looking at those for acceptance during construction as a contract requirement, that seems like a big challenge for at least this contractor. And I don't know if you have any insights there.
Yeah, Tim. I again, as I actually added one to spend a little extra time on the quality assurance item, as I think that's really coming into focus for a lot of people, is what is going to be necessary to bring this to quality assurance and into the field is going to be different than just providing it and bringing it to mixed design. There are those other considerations, and things like the cracking test have a certain amount of variability, and there's a certain frequency that you can achieve with them. Is that going to be sufficient? And is that going to be enough to handle the risk to get to performance for an agency? I'm not sure that's necessarily proven out at this point, but I think that's where the national eye, if you will, is going to turn now, is to address those challenges and get some answers.
Yeah, I think one thing might be worth mentioning that we've added to our workshop that we delivered recently was a statistical analysis in terms of the number of samples. And I don't know, I think that might be
Yeah.
something to add as well, since it is such a big area of concern.
Yeah, Tim, that's an excellent point. The thought of, when a lot of quality assurance specifications were put together, a statistical analysis of the tests that you were doing and the variability those tests have lead to really kind of your risk of making a wrong decision, a wrong decision or an inaccurate decision in acceptance. We got to do similar things like that in balanced mix design, and we show in our workshop a table that Tom Harmon of NCAT had put together. So credit to him to putting that together, that show the impact of the number of samples you take and the number of replicates you test. And the confidence that you have in that test result is actually indicative of the material you have. Those are things that we're going to have to do with these balanced mix design tests if we're going to bring them into quality assurance. And that frequency is going to come up with that how much risk are we willing to take?
Very good. Yeah. So the variability is there certainly, but hopefully we'll learn more to try to reduce that. Next question from Pennsylvania. This is looking like a validation challenge. They've been collecting data. They have pavements out in the field since 2020, so they might be maybe 3, maybe approaching 4 years old. So they have some tests results. They have limited field performance, but 4 years isn't that old to come up with a cracking standard. So certainly the validation was, Derek, one of the ones you mentioned that's a big challenge. And so when is the best time to start the validation?
You teed me up, Tim. You teed me up for one of my favorite sayings with balanced mix design, and specifically with validation. With the concept of validation, the best day to start was yesterday, and the second best day was today, and the third best day tomorrow. Time is the enemy. If you're putting down field sections, if you want to be able to have that field performance comparison with balanced mix design tests, which you really need in order to come to rational criteria in some way, shape, or form. You need some sort of comparison between field and test and lab test. Time is your enemy. So yeah, if that's my biggest to implore some of the participants here, that if you're interested in balanced mix design, that's not something to wait till year 3 to think about. It's something to think about very early, as time is the enemy. So I echo the thoughts from Pennsylvania there, that again, 2020 feels like forever ago in a lot of ways, but it really wasn't that long ago in the life of an asphalt pave.
And along the validation lines with the challenge there, I think since it's concern of so many, it might be worth mentioning the Capri has put together that document. I'm going to type the link in here. And
yeah, Tim. Yeah, if you put that link in, that'd be great. Capri, Consortium for Asphalt Pavement Research and Implementation or Innovation. I'm sorry, I forget what the I is all the time, but they have put together a document on how to set up a validation experiment and learn from a lot of the field experience, and has a lot of that information. So that's an excellent resource that Capri has put out there in recent months, I think the last 3 months, that really provides a really good guide for agencies that are looking to do that type of experiment.
Yeah, the I's for implementation. So we're all about implementation. And
that's right.
And the one thing I would add is a great way to do this is with the test sections that you build in your state. We certainly encourage that. But in the document, there's other techniques that might be faster, like NCAT and Menroad have test tracks, and test sections can be built. There's accelerated load facilities in various states, FHWA and others. Some other opportunities exist. So one thing is to certainly take advantage of those. And I think that Capri document goes through a variety of options, and taking multiple approaches is something that we commonly see states that have implemented. They don't just do one thing, field test sections. They usually do a couple of approaches.
Yeah, I echo your comment, Tim. From what we've seen from those states, we are often seeing not one thing lead to criteria, that there's a lot of information that feeds into that criteria. So it can be from many things, knowing that none of them are perfect, right? None of them are perfect in every single way, but they all feed into a decision to again, come to a rational and defendable criteria.
Very good. Um, Next question is from Toronto, and they're just starting to get into balanced mix design and are a little concerned about how long the testing turnaround time is for various labs. If you want to do the mix design, and then of course another component is when you go to the field for acceptance. Our major labs turnaround results in about 2 weeks, but just wondering, and I assume that's 2 weeks for balanced mix design, and they're just wondering what the turnaround is like in the US.
Yeah, I think it obviously varies for those that have implemented each one because what they're doing in mixed design depends. I'd even say, I think that's a good question. I think that the turnaround is certainly part of it for a test like the Hamburg wheel tracker, that test takes, 6, 7 hours and you've got to fabricate. So you're talking multiple days, could be a couple weeks. I think maybe the challenge to also think about that maybe we don't talk about when it comes to the frequency and maybe need to clarify that a little bit is throughput. Is what is the throughput? It's one thing to turn a test around in a certain amount of time. You could turn an ideal CT around relatively fast. I think what's harder is the throughput, the amount of effort that it takes to fabricate and test a BMD test is more than we currently do under volumetrics. So if you want to think about it as throughput, maybe your lab can handle 10 volumetric samples a day. It probably won't be able to handle 10 balanced mix design samples a day because of that added effort to specimen fabrication and preparing it. Again, the tests are generally pretty quick, especially on the cracking and something like the ideal CT. But I think it's more of that throughput that you might get it within 2 weeks, but then if you get samples at your current frequency, you won't be able to keep up because you have a backlog.
Very good. Yeah, we have the Capri document. The link to that document for validation is in the chat, so we encourage people to go to the website there to get that. Next from Maine, we're hearing about the pavement layers or the various lifts. Certainly that's something that's included in the definition, but is anybody actually taking that on? If you have a surface lift, or if you have an intermediate or base lift, or would you do anything different in terms of your balanced mix design in terms of setting criteria or how to address that?
Yeah, I think it's an excellent point brought up by Casey there, that in the definition of balanced mix design, as you cited, Tim, it's right there in the definition that how you use the mix should matter. And I think that makes sense to us asphalt engineers. How they fail is different depending on how you use it. I'd say that there are states that have implemented and they have different requirements depending on how they use that mixture. And maybe it's not as required for flexibility if it's in an intermediate layer. I'm not sure there's any specific resource that provides guidance on the link between pavement design considerations to balanced mix design. I'd say more that there are examples from states that are using that context specific, how the mix is being used on their criteria and having varying criteria based upon their expectation. Often, as you note, a surface mix, we ask a lot of our surface mix, right? Because there's a lot of stresses right at the surface. And that maybe that expectation does not need to be as high the lower you go, except in some cases where agencies want a really flexible lift in their very bottom layer in order to resist fatigue cracking, in order to have a perpetual pavement. That's an example of this type of approach. I guess, nothing exactly comes to mind, but I think there are the examples of having that different approach depending on the type of mixture and how you're going to use it.
Very good. Yeah, so a lot of challenges out there. Appreciate everyone typing in where they're at and the current challenge they're facing, and knowing that you're not alone. There's a lot of other states in the same situation, and other states that maybe even are in the lead or ahead of you per se, that have found some successes that can streamline the solution to your challenges. I guess shifting gears a little bit, Derek, now I would like to ask about the successes. There's a lot of challenges here, but uh, certainly if we have successes out there, that's nothing better than seeing how someone else successfully did it to help me overcome a challenge. And I don't know if there's uh, any of these where you've seen a success you want to highlight. But while you think about that for a minute, I'm going to ask our participants, as we go through these challenges, which one have you kind of checked off the list per se? Where have you seen a success? You have something that might be able to help other states. We are really looking for good examples out there of successes and trying to document those to help others. So feel free in the chat pod to type any successes you've seen, and then maybe we can see from Derek some of the successes he's been impressed with around the country.
Yeah, I think it's important so we don't get too down and just talk about the challenges and the problems, talk about the successes. I think, there are certainly some examples that come to mind. Some, I think, the state of Illinois has done a lot in balanced mix design and been a leader with their implementation of the iFit and the Hamburg wheel tracker, things that I'd specifically look to them for as successes as the different ways that they tackled validation and the multiple approaches that they took there. I also think they're an example of driving out variability with their interlaboratory studies that they were able to do over numerous years. Other examples that come to mind as well on the more management side is I think that Virginia is a state that has come a long way in balanced mix design in recent years. I think their planning process and their stakeholder engagement was really well thought out. They had a big they had a timeline with major milestones thought out. And yeah, has it changed a little bit? But they've been able to keep relatively close to that through a lot of their work and keep to that. I also see that their stakeholder engagement setup was really good. They did not have one BMD group. They had a parent BMD group with stakeholders in industry that kind of looked at the full picture, kind of the larger picture of implementing balanced mix design. And then they had technical group that got into the details of the testing and things like that. I think that's a very good example for larger states that have enough group to, differ in those ways. And I also want to acknowledge one more recent that Rick Bradbury from Maine mentions that Northeast is getting together on that collaboration challenge. The Northeast, given all the smaller states, is trying to get together and come together on things like specimen fabrication, et cetera. I think that's another thing that could be replicated in other places to try and reduce variability in between how states do it. One last one that comes to mind is, again, on the key item. I know I've hit validation many times here, but I think the states of Wisconsin and North Dakota have, early on in their process, they thought of validation experiments. They put out test sections, or in the case of North Dakota, putting out test sections. Those are well thought out validation ways. So I think even though I listed as a major challenge, there's examples of very good success in how that's being done out there.
Very, very good, Derek. Several good examples. And I think that's probably going to be, as I see it, our next challenge. Our next challenge is to document those successes to help pave the way, if you pardon the pun, or to help blaze the trail for implementation of balanced mix design. Nothing like a good example to help overcome a challenge. So you've already acknowledged Rick's comment in here about the stakeholder engagement with neighboring states, and I'll go back to Utah where they have a success in terms of using the Hamburg wheel track test. They have the high mod binder, very high polymer, not your typical polymer modified binder, but probably twice the polymer loading. And the 3 to 5% air voids is pretty much out the window. They can go to very low air voids below that and still get rut resistance and still get good density, high density in the field for performance. So there's a success story of using balanced mix design to think outside the box and get a superior performing mixture. So thanks for sharing that.
And Tim, I just want to add real quick that I think even listed with all these major challenges, these critical challenges that we've listed, I think, you could come up with an example for each one of these where somebody is having successful practices. Even the one like Pathway for Field Quality Assurance that I spent time on. New Jersey is a state that has been doing that. It has examples of doing some of those things for some of their specialty mixtures. So I think, there are examples, a lot of examples of progress being made at the very least on all of these challenges and ways. And I think our next step is, now that we've listed out the challenges, I think that's half the work, is to know, acknowledge them. And now many groups can acknowledge these and say, where are we on this, and share information on what's been done on it.
Very good. Yes. We certainly want to acknowledge that change is pain, as you said, and we're not going to be able to remove that. We want to be sensitive and empathetic to the steps that it's going to take. At the same time, we hope to assist states as going through that process to identify some success stories. Some may apply to your state, some may not, but at least if you have options, it's good to have options. Okay, so another success story here from our Eastern Federal lands. They're implementing balanced mix design as an addition to volumetric properties, and there's no minimum asphalt content. And they were able to take a drier mixture and get about 3/10 more AC added, which was an improvement, and increased the SAP, the cracking value, in compliance while maintaining volumetrics. So
Yep.
3/10 AC got them a more crack resistant mix, and I guess that looks like approach A, where they're doing volumetrics and adding a cracking test. So thanks for sharing that. Okay, very good. Well, we got a lot of good challenges, discussion, and examples from participants. So a lot of good discussions on successes and examples. If anybody has any more questions, feel free to chime in. Oh, here was one that just came in. This kind of goes back to the challenges, maybe back to the one that Casey from Maine was mentioning. But so say you have an overlay project and you want to do balanced mix design, and say you have some new construction where you're starting from the subgrade up and you want to do balanced mix design. Would you do use the same balanced mix design specification for both?
Yeah, I think the simple answer is probably not. I think that context specific part of it, you may or may not even do the same test potentially. It is possible that you could ask for different tests for different applications. Again, that adds in another challenge of adding tests and things like that. But I think certainly you want to think about how it's being used. And, in an overlay situation versus, bottom lift of a full reconstruction, we are asking different things out of that mixture. And our requirements for the contractor to make a mix should be different as such. That is something to think about when you get to validation, setting up validation experiments to reflect the different uses. And again, this brings me back to goals and scope, knowing what am I looking to apply balanced mix design to. If I don't know that, then I can't properly set up my validation experiment, which means I can't properly develop criteria. So I think a lot of it starts with knowing what you're looking to get out of balanced mix design as a starting point. And that leads me to a point that I feel necessary to say, to remind everyone that balanced mix design, although Federal Highway, others are putting a lot of energy into it, it cannot be said enough that balanced mix design is not a cure-all. Balanced mix design will not cure field issues, not getting density, applying the wrong treatment to the wrong road. There are things that we can do, but the mention of an overlay, unless we're specifically designing it to handle reflective cracking or something along those lines, it may not be a cure for all. So make sure to acknowledge that in your goals and scope, because otherwise you may be thinking, people may think that you're promising something that you can't deliver on, because balanced mix design can't fix those other things.
Yep, nothing like inadequate tack coat with a superior balanced mix design mix and expecting it to perform. Balanced mix design will give you a better mix, but like you say, it can't solve everything.
Yep.
Okay, we have another success story here from Maine about pre-implementation, and that's centered around communication, collaboration with their internal upper management, as well as externally with their industry partners and then regional partners with neighboring states. And here, Casey from Maine says you can't do it enough, but communication, collaboration early and often with all parties. Uh, After seeing that, he wished he would have started even sooner, but congratulations for doing that as you did, and hopefully your experience and words of wisdom will help others on the webinar today. Looks like we got a couple of nice thumbs up on those comments as well.
And I guess just to add to that, Tim, I think it's an excellent point by Casey. Again, I think that, to add upon that, I think sometimes agencies might start with, well, let's check this balanced mix design thing out and let's not bother industry with it until we have a plan. And I understand, having been and worked for an agency, I understand that line of thinking. I do think that stepping away from that is good, because the goals and scope, if you want buy-in from everybody, then you would think that industry needs to at least be part of that conversation, right? And be part of that. Whereas if it's kind of kept close to the vest for a period of time and then it's brief on it, are you really going to get that same buy-in? So I echo that thought that oftentimes that feels maybe the opposite of what we might want to do. I think balanced mix design certainly falls into the bin of communicate early and communicate often.
Great. Okay, well, I think we've exhausted the chat pod of this last call. If anybody has something pressing to put in, and while you're thinking about the last call, I'll thank you again, Derek, for the great presentation. Appreciate all the audience participation with the questions and comments to make it a more lively session. Very, very nice to see all the comments come in. I think, Ellie, you want to come in with a couple closing comments?
Yes, thank you very much, Derek and Tim. I think that was very, very good and excellent discussions. And we have, as you notice, we're recording the webinar live. So in the next couple of weeks, keep checking our website so you can have access to the webinar and the relevant information that the documents that Tim shared in the chat box today. Also, would like to ask you to take a brief survey. It is, I'm gonna put it again. It just will take you only a few minutes, less than 5 minutes, to tell us how we did today and where we can improve for our next webinar.
And I guess I thank you, Ellie and Tim, for the opportunity to present this work. Certainly, I want to acknowledge the two of you for working on this, as this is something that we've worked on together. I also want to acknowledge all the agencies that participated in the peer exchange, gave their time to provide feedback on these many things, as well as industry, NAPA, NCAT, other opportunities and organizations that are all working in this balanced mix design space. I really do feel like there's a coalescing together of the asphalt pavement community and trying to advance balanced mix design forward. And another thing I just want to share is, now that these challenges have primarily been identified, I think a lot of groups nationwide are going to have a nice blueprint to start working on these and try and clear some of these challenges. I know Federal Highway will be working on bringing information on these. I know Capri is an organization that will look at these, as well as mentioning that the National Asphalt Pavement Association is putting together a balanced mix design implementation working group that's going to consider these. So I appreciate everyone's participation in this whole process as we as a community try and bring this forward.
Well said, Derek. Thank you. And it would be good to close out. However, we do have somebody took me up on my last call. So I think we will have one more question before we close out, but I think it's a good question. And so when other state DOTs are starting to do some pilot projects with balanced mix design, what mechanism did they yield in terms of how to do that? And certainly I think through our workshop we're aware of there's not just one way to do it, there's a few, and so I don't know if you want to touch on that.
Sure, and I think it's an excellent question. And number one, I'll direct you to that Capri document as well on that's specific to field validation. I think that's a good one. But some have done it what I would characterize as a more materials approach, where they don't specify balanced mix design values. They specify, give me a section with high RAP or more RAS or a different binder grade or something like that. And they take the more materials approach to get different sections within a given project. That's one way. Another way is to actually specify balanced mix design values. Say, give me an ideal CT of X or a Hamburg wheel tracker of Y, and specify that. There's some pros and cons of each approach when you're talking about creating field validation sections. One of the cons of the specifying values approach is that the contractors may not be set up to meet those specifications yet, right? Because you haven't implemented balanced mix design. So they may need help in order to hit a certain number. So the materials approach may be easier, but will you get that differentiation? So again, I think that's a detail, but even when we just say, well, do validation projects or look at accelerated loading, how you do that is some variation between the different states. I think it all depends on the given situation you're in.
Okay, very good. And so with that, I will go ahead and close this out. I remind you our final webinar for this cooperative agreement is going to be March 7th. We're going to review all the products we created over the last 5 years and the reason why we created them in relationship to our FHWA strategic goals. Ellie will be delivering that webinar. Although we're sad the webinar series coming to a close, I do want to remind everybody that we have a new cooperative agreement that's starting, and hopefully we'll be able to start a new webinar series in the near future. So I look forward to seeing you March 7th, if not before, and hope everybody has a good holiday weekend coming up. Thanks, everybody.
Thank you, everyone.